Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're doing lesson 53 in your blue book, and it's all about scientific notation. And we start to understand scientific notation by understanding what happens when we multiply a number by a power of 10. So we start with 0.0534 times 1,000. And remember, 1,000 is 10 to the third power, and 1,000 has 3 zeros. So when we're multiplying by a power of 10, we move the decimal from where it was before, the number of places that we have zeros, or the exponent on the power of 10. So they're both 3, so we're going to move 3 steps to the right, because isn't our number getting bigger? So when our number's getting bigger, we're moving the decimal to the right. So we moved it 1, 2, 3 steps to the right, which now, instead of 0.0534, we have 53.4 or 53.4. And our rule is here. It says, when we multiply by a power of 10, we move the decimal to the right, and I ran out of room, so let's finish it. We move the decimal to the right, the number of zeros, or the power that is on the 10. Okay, the exponent, the number that's the exponent, that is 10 to the something, we move it that many spaces, or the number of zeros in the number in its standard form. Okay, so now we're learning about scientific notation. Scientific notation is using exponents to make numbers easier to do math with. Okay, so we have this big number that has lots of zeros. In order to put this number into scientific notation, we're going to do two things. We're going to move the decimal, and then we're going to write a number, a power of 10, with an exponent that's going to take care of undoing the decimal that we just moved. So we can't move decimals without changing the number. And we're not trying to change the value of the number. We're trying to change the representation of the number to make very large numbers and very small numbers easier to read and also easier to do math with. Okay, so here I'm going to move my commas. Okay, we have this big number. Now, wouldn't you agree that right now my decimal is there? Okay, and any number without a decimal, the decimal is at the end. Now, we always are going to move, for scientific notation, we're going to move our new decimal right after the first non-zero digit. So in other words, I've got to move a decimal right behind the 7. How many spots is that? I'm going to move it 1, 2, 3, 4, 5, 6 places. Now, when I move the decimal 6 places to the left, I really divided by 10 to the 6th power because I moved the decimal to the left. I don't want to change my number, so in order to fix it and make it represent the original number, I'm going to have 7.024000, and we're going to adjust that in just a minute because we don't need all those zeros because our decimal's way over here, times 10. Since I just moved it 6 to the left, I need to move it 6 to the right over here. Okay, so won't multiplying by 10 to the 6th take the decimal back 6 places to the right? Okay, so like I said, I don't want to change my number. I'm just I'm representing my number in a new form. Scientific notation is used a lot to help us do math with very, very large or very, very small numbers. Now, I'm not going to leave these zeros here. These zeros right here are absolutely meaningless because they come after the decimal and they come after the last non-zero digit. Now, this zero I can't get rid of. This zero is holding a place. But those 3 zeros at the end were holding nothing. So now this is my new number, and this new number is in scientific notation. Okay, so we would say 7.024 times 10 to the 6th is the same thing as, let's get back to our original number here, comma, 7,024,000 is the same thing as this number, because this 10 to the 6th is going to move this decimal 6 places back to the right. Okay, this one's not quite as big, and the original decimal is kind of in the middle of the number. So 476.24 is not really that big a number, but we are told to put it into scientific notation anyway. So I'm going to use that as my abbreviation because I get tired of writing it over and over. So now, remember, to be in scientific notation, we need to move the decimal 2 places to the left to be right behind the first non-zero digit. So now I'm going to have to move it to the left, so I'm going to get 4.7624. But I don't want to change my number, and I just did. So I have to undo my change. I moved the decimal 2 places to the left, so I must move the decimal 2 places to the right. So it's kind of like a do and an undo. Okay, it's getting the decimal in the right place and then compensating for the fact that I changed the number and taking it back to the original number. We don't want to change the number's value. Okay, now sometimes we have to move our decimal to the left. And when we do, we use a negative exponent, showing that I'm going to take 3 steps backwards. So when I have 4.76 times 10 to the negative 3, this number is in scientific notation, and now I'm going to turn it into standard form. So I'm going to write this number in the front and then say, okay, this is not the real number. The real number has a decimal 3 steps to the left. So 1, 2, 3. Put your new decimal there, and the new number, the number that this really is supposed to represent, is 00476. And now we're learning to go back to standard form from scientific form. Okay, so here we have an example that is taking a number that's not in scientific notation. This is called standard form, and we're turning it into scientific notation. So we must put our new decimal in the right spot. So our new decimal has got to go right behind the first non-zero digit. So our decimal's got to go there. So we're going to have to move it 2 to the right to get it into that spot. So 6.52. And I moved it 2 to the right, so to get back to my original number, I will move it 2 to the left with multiplying it by 10 to the negative 2. Multiplying it by 10 to the negative 2 is really dividing it by 10 to the 2, which is dividing it by 100. So if we did this, then we would get our 2 steps backwards, which would take it back to the original number. Isn't this cool? Okay, so now we have 2 problems in one example. We're going to take these 2 problems that are in scientific notation, and we're going to put them back into standard form by doing what we're supposed to here. So 4.6 would have a decimal here, but that's not my real spot for my decimal. Okay, this is the scientific notation. What does this number really look like? So now I'm going to take my 10 to the negative 4, means move it's really dividing by 10 to the fourth, which means move my decimal to the left 4 steps. 1, 2, 3, 4. 0, 0, 0. So now the real number is 0.00046, and its scientific notation is what we started out with. Now here we have 4.6 times 10 to the positive fourth, which means we're going to take the decimal. I'm going to do this one up here. Okay, we're going to take the decimal and move it 4 steps to the right. 1, 2, 3, 4. 1, 2, 3. And the number is 46,000. If we want to, we can put a comma in there. Okay, so multiplying by 10 to the fourth is multiplying by 1 and 4 zeros. That's the same thing as 10 to the fourth. And it moves the decimal 4 places to the right. Multiplying by 10 to the negative 4 is really dividing by 10 to the fourth. And it takes the decimal 4 steps to the left. Okay, so this is your first and second practice problem here. So I want you to put this number and this number that are in standard form and turn them into scientific notation. So pause your video and give it a shot. All right, so the first one is we're needing, remember, to put it into scientific notation, we always need the decimal to move right behind the first non-zero digit. And 4 is a non-zero digit. So here is my current position of my decimal. So now I'm going to move the decimal and keep track of the number you move it. 1, 2, 3, 4, 5. I moved it 5 steps to the left to get 4.76000. Okay, now we're going to erase some of those zeros because we don't need them. But the important thing is our decimal is here. And then since we moved it 5 steps to the left, we're going to multiply it by 10 to the 5 to take the decimal back 5 steps to the right, so I get back my original number. So now, do we need these zeros on the back at all? And the answer is no. So we're going to end up with 4.76 times 10 to the 5th. We could go ahead and move the 10 to the 5th up there. It looks better. Okay, so that is this number when we put it into scientific notation. So now look at this one. This one is not in scientific notation. This is the standard form. So we're going to turn it into scientific notation, and we have to move our decimal right here after the 4, because the decimal always goes right after the first digit that's not a 0. So now I'm having to move 1, 2, 3, 4 steps to the right. So my new number is 4.76 times. Since I moved it 4 to the right, don't I need to move it 4 back to the left in order to get my decimal back where it started? So what I'm trying to get you to see is we are not changing numbers. We are re-representing in a different form the same number. Okay, we have 2 more numbers to put into scientific notation, and then we're going to take a few and put them into standard form. So now we're turning these into scientific notation, and this is your practice. So copy down your numbers and pause your video. Okay, so I'm going to go ahead and take off the comma for right now, because my decimal, which is currently here, must come all the way and be right after the 3 for it to be in scientific notation. So what I'm going to do is I'm going to count how many places my decimal is going to need to move. 1, 2, 3, 4, 5 steps backwards gives me 3.05600 times. Now, I don't want to change my number. I just moved it 5 steps backwards. So I'm going to undo that by moving it 5 steps forward again. Multiplying by 10 to the 5th is multiplying by a 1 with 5 zeros after it, and it moves the decimal 5 places to the right. So now the only thing I need to do is to fix the fact that I have 2 zeros here that are meaningless. Trailing zeros after the decimal and after any non-zero number, they're meaningless. Okay, but this 0 is a placeholder, and he has to stay. So this is the scientific notation for the original number, which was starting right there. Okay, that was the original decimal. So now let's look at this one. And we have to get this standard form. We have to write the scientific notation. And again, my decimal needs to go right after the 3. So I'm going to have to move it 1, 2, 3, 4, 5, 6 places to the right to get it in the proper spot. 3.50, excuse me, I lost my 0. 3.056, and I moved it 6 places to the right. So now in order to undo that, I'm going to move this 6 places back to the left. So this is a do and an undo. I moved it the 6 places to the right, and then I indicated that I need to move it 6 places back to the left by multiplying by the -6 exponent. And there you have it. So now we're going to do 2 more practices that are going to involve going the other direction from scientific notation to standard form. Okay, so here is the last little bit. This is another set of practices for you, so pause your video. Okay, so here we have 10 to the 5th, which means we're going to move the decimal 5 places to the right to discover what this number really is. So we've got 4.06. We're going to move 5 places to the right. 1, 2, 3, 4, 5. Fill in with zeros, and this is the number that this represents. So if I get rid of all my little curly cues here and I put a comma, then I can see that this number really means 406,000. Okay, so the last problem. We have 4.72 times 10 to the -6. Let's see what is the real number here. So we're going to start with 4.72, and we're going to go 1, 2, 3, 4, 5, 6 steps backwards, and 1, 2, 3, 4, 5 with a decimal right there. Okay, so wow, that's a lot of zeros. We had the decimal here. We took 1, 2, 3, 4, 5, 6 steps back, and that's a really, really tiny number. But it's a good number to try to read. So let's see if we can get this straight. Remember, this one is the tenths place, and the hundredths, and the thousandths, and the 10,000ths, and the 100,000ths, and the millions. Okay, and then the 10 millionths, and the 100 millionths. So we'd have 472 100 millionths. You can see why a lot of people just say 0.000000472, can't you? All right, so we are done with lesson 53, and it's kind of fun, wasn't it? Going from standard form to scientific form, and going from scientific form to standard form. And this is Mrs. A, and may God bless your day.